This is the brief on helical fluid flows. So today we're looking at an analysis that really gets into the nitty-gritty of dynamics and mass flux of helical fluid flows. Basically, it's all about figuring out exactly how a fluid with constant density spirals through a cylinder, without losing its shape. And it uses some pretty complex math to do it. Okay, first up, let's talk about mass flux. That's really just a measure of how much fluid is moving across a specific surface. The study looks at three of them: a flat horizontal slice, the vertical outer wall of the cylinder, and then a vertical slice that cuts right through the middle. And here's a key finding from the theory. The flux through that outer cylinder wall is calculated to be 0, which makes sense, right? The fluid can't go through the wall, so it just slides along it. Second, what does the physics of the flow actually look like? Well, a couple of things. The flow is incompressible, which means the fluid never gets squashed. Its volume always stays the same. And it also has what's called rigid body rotation. You can just picture the fluid swirling together like a solid spinning object, instead of tearing itself apart as it spins. Finally, all those equations can be tough to picture in your head, and that's where this analysis really connects the dots. It uses a 3D simulation to let you see the particle paths and calculate that mass flux in real time. You can literally watch the flow interact with the boundaries, visually confirming why that mass flux through the cylinder wall is 0. So, by combining these rigorous calculations with powerful 3D visualization, we can fully understand how an incompressible, rotational fluid behaves in a helical system.